Good morning, good afternoon, and good evening. Thank you to everyone for taking the time out of your busy day to join us for a very special web event. I'd now like to pass the floor to our presenter today, Robert Ferrulo, who's a Senior Technical Marketing Engineer with Mojo Networks. Robert comes to Mojo with over 20 years of experience in the networking industry and nearly a decade in Wi-Fi, along with 15 years of 15 years of experience in performance testing. Today, we're going to kick off the final installment of our three-part series around campus networking. In this particular session, Robert will be taking you through the management best practices for your campus network. If you missed our first two webinars around best practices for campus network design and deployment, you can go ahead and visit our on-demand page on our mojonetworks.com/webinars, and you can go ahead and view those as well.
All right. Thank you very much, Erica, and welcome all. We got a lot to get through, so I'll just quickly go through the agenda here. We'll do a quick recap for parts 1 and 2. And then we'll talk about the introduction for this particular webinar. We have a unique approach to network management and troubleshooting and optimizing, and also we'll just set the context there. And then we'll go through the management process, which we've broken down into a monitor, planning, troubleshooting, and reporting. And then we'll just quickly go through 5 different issues that may, fairly common types of issues that you may encounter, and then how to actually rectify or remedy those situations, followed by Q&A, and then we'll talk a little bit about the free AP. Okay, parts 1 and 2. Well, first of all, the series, it's a 3-part series. The first one was channel capacity planning best practices. Then we went through deployment best practices for, of course, 11AC, Wave 2 wireless LANs. And then finally, this one, network management best practices. For session 1, we talked about capacity planning and the need for capacity planning, basically trying to find out how many APs or how many channels, how much spectrum do you need in a given area to meet the use case requirements. We looked at AP placement and channel planning for instance, using Mojo Planner to understand how many APs you're going to need for a given environment. Then we also looked at some campus use cases. And we worked out some channel capacity planning, basic, simple, two-step process to come up with the number of APs that we would need for a given use case. And the session 2, we looked at, we talked about site readiness. That was one that we put together. We put together a little checklist to make sure that before you do a truck roll or visit a site or have a team of deployment specialists visit a site, to make sure that you have everything that you need to make sure that the deployment goes well. Then we went through wireless LAN deployment best practices, followed by LAN deployment best practices, and then AP channel deployment and network services best practices. So we welcome you to, if you haven't seen those, if you can get those on demand, and I think you'll find those useful. All right, introduction. So for this particular webinar, it's a unique, not unique, I'd say, but it's from a particular perspective. Really, it's a proactive method where we're going to be looking and actively going out, looking at key performance indicators, and really trying to be fully aware of the network. I mean, this assumes that at least one person can spend some time, not all day, obviously, but on a regular basis, monitor the network and be on the lookout for any anomalies, or you're doing trend analysis to make sure that you're aware of how things are changing in terms of utilization or any types of issues that may be popping up more frequently, and so on. And it's really from a network health and performance perspective. It's not from the security perspective. We've done webinars on network management or security, wireless network security and management, and so on. And so those are available. We welcome you to get those online. But this one, really, we're talking about making sure that the network's up and running and the applications are performing, and devices you're managing device health and so on in terms of network access and performance. So we're going to talk about some optimizations in this webinar. But like most choices in engineering, of course, there's usually a trade-off. So we're going to try to take a methodical approach to it, and so that we make sure that when we try to fix one thing, and we don't break something else. Because with network optimizations, there are you have to be cautious. Okay, network management process. a simple process. It's an iterative process. Uh, for those of you that have been doing this for a long time, I'm sure you do something like this. You're going to monitor the network. You're going to look for key performance indicators. You're going to take, come up with some course of action that you're going to take, whether it's upgrading the APs or upgrading client drivers, and you're going to try to do this in a methodical way. And there may be some troubleshooting involved. And they may, then for also optimization to, so you're going to optimize and or troubleshoot, and then you report and so on, and monitor again and plan, and it's so it's basically an iterative process. And so, as far as like how the network's performing, you're going to want to keep a close eye on key performance indicators to get the health of the network. For instance, retry rates, channel utilization rates, MOS or mean opinion score for voice, average TX, RX data rates, AP uptime, internet uplink utilization. I put that in there because obviously that's not a wireless LAN key performance health, because internet uplink is internet, not your wireless LAN. But a lot of times problems can be related to oversubscribing the internet uplink, because these days we have a lot of applications and services are hosted actually on the internet. And so, of course, we want to make sure that we have plenty of capacity there on the uplink, and that way we know that we're not oversubscribing, and that could be the bottleneck, for instance. Noise floor on the wireless LAN side, and average client RSSI. Now, there are lots of places to go to look at these key performance indicators, and we'll talk about some of those in the next few slides. Well, you have built-in wireless LAN performance tools that you can also use. For instance, our APs have iPerf built in, so that you can run an iPerf test or a throughput test to a client that also has iPerf. So you have that as one of the tools. Packet capture analysis tools, Mojo packets. That's of course our own unique graphical-based troubleshooting tool. Our APs can do the packet capture, and they can do the packet capture without interrupting the service, right? So it's not in service impacting. You can do a packet capture, put that up into Mojo packets, and take a look at key performance indicators there, and the health of the conversations between the clients and the APs. Also, user interviews and surveys. I don't know how many people make use of these. Probably we're just used to waiting for people to call the help desk. That's, of course, another place where you can get information about the health of your network is by running periodic help desk reports in terms of the frequency of the problems, the type of the problems, which client types are associated with problems, which would indicate maybe there's a particular type of problem with maybe a driver on a particular client device type. But the user interviews and surveys can be really helpful as well, because if you proactively go out there and you ask them very, targeted questions about how, what this application is performing, or that application, or, how's their experience in this part of the building or that part of the building, and so on, then you can usually find out more than just trying to get information from the help desk, because a lot of times people will just live with problems. They won't necessarily report it to the help desk. They'll just, Wi-Fi is the problem again, or perceived problem, and they just kind of live with it. So if you can set up, some easy to use surveys, then maybe you can find out about problems before they become huge, and a real impacting your business. ABC, so application visibility, looking at what applications are being used, and maybe some applications that are taking up too much bandwidth that you weren't aware of, but you can find out by looking at your application visibility. And then application testing walkabouts during peak utilization. This, of course, is time consuming, but it's one of the best ways. If you try to run, say, video streaming or video conferencing or voice on mobile devices when, it's peak time in the area of the network which has the highest utilization, that can be very helpful to see. It's a good way to find out if you have enough capacity there in terms of, spectrum, channel capacity, and so on. Application device reporting. Some devices, like, for instance, the Cisco 79 series, 7925, and the older 7921, they actually can report MOS right on the handset, which is really cool. So you can look at that, or you can look at the app MOS being reported in like Link or Skype for Business. You can go and they have a screen where you can find out the application, what it's seeing in the way of MOS. Heat maps, you can go on, our system, of course, and look at the heat maps and see what the coverage looks like and the average signal strength and so on. And connection logs, that's another feature where you could go and look at the conversation that the client's having, with the access point. And then there are third-party solutions like Seven Signal, which does network monitoring of network performance monitoring. And so there are lots of ways to get information about the health of the network, obviously. And I'm sure there's some I left out here, but that's a pretty long list as it is. And then cataloging the issues. So yeah, just to keep, well, I guess it's all about keeping notes and that way you have something because it's so much to remember. So if you can catalog the issues, then your help desk probably would have, tools or support system would help you with this in terms of the types of applications. So you could run a report maybe on see how many times the particular application had a problem or a particular type of client, and then keeping track of the location, time of days, and then combining it all to kind of develop a picture of what's going on. So if it's voice, for instance, in the the east wing, second floor between a certain time of day, and so keeping things cataloged that way and organized and recorded can help you get to the bottom of the situation, or even to do some proactive optimization before it becomes much of a problem, or a bigger problem, I should say. And trends analysis, this is also trying to stave off some kind of network outage, right? So if you're constantly and proactively doing trend analysis, you can predict, or you can maybe fix a problem before it's even noticed. So you can if you're looking at utilization levels, channel AP, switch uplink, internet uplink, retry rates, and packet loss, and so on, latency. If you're keeping an eye on all of those key performance indicators, then you can potentially nip a problem in the bud. Other types of trend analysis, band usage. Over time, I'm sure most of you have seen these 5 gigahertz band being used more than the 2.4 gigahertz band. But sometimes it's still, you want to get used to that 2.4, especially if you're in an environment where you cannot use the DFS channels for some reason. Maybe it's because you have a lot of clients that don't support DFS channels in the 5 gigahertz band. So you're going to want to try to get the most out of both bands and try to squeeze out as much as you can out of 2.4, as well as the 5 gig, the limited 5 gig and limited 2.4 available. Client population, Mac versus Windows, etc., or iOS versus Android, and 11N to 11AC client ratio. Obviously, one of the best things you can do for your network in terms of making use of the spectrum available is to have more 11AC clients, because they're going to use the spectrum more efficiently with 256 QAM, with transmit beamforming, and so on, wider channels, etc. So you want to keep an eye on that, and also 11AC Wave 1 to Wave 2. 11AC Wave 2 clients, you're going to get the biggest bang for your buck if you have Wave 2 clients and Wave 2 APs, because with multi-user MIMO, we won't go into that here. We have in the past, but the ability to talk to up to 4 clients simultaneously, and so you get that switch-like behavior, and that is a big, really a game changer for Wi-Fi. It really does. In our lab testing, and not just our lab testing, but other third-party reports that we see available, it shows that we really do get a better efficiency, more efficiency use of the channel capacity, and that can make or break the success of the network, especially in high density areas or high throughput areas. And then application usage adoption, and you can get that again through ABC, the application visibility that's built into our system. In BYOD trends, what type of device you're getting, and then keeping track of your MOS and MIDI averages, so you can get the kind of keep that. And again, there you would look into your if you have Link or Skype for Business, and other systems too. That's not the only system that can report MOS. MIDI though, that one there, I'm not aware of any third-party system. I thought that Skype for Business had some type of statistics for the video conferencing as well, but I don't know if it's MDI, which is the Media Delivery Index. Maybe like VBrick or High Vision and some other third-party video streaming servers have the ability to report Media Delivery Index, but that's one for it's basically a MOS for video. Media Delivery Index looks at your delay factor and your media loss rate, and those two make up your MDI, your Media Delivery Index rate, index. And so, that's something you want to keep an eye on too, because video is huge. Obviously, video and video conferencing are a big part of most networks these days. And one of the most challenging applications, obviously, or challenging types of applications, video. All right, and then APIs. With Mojo Networks, we have a full complement of APIs, and we use these to integrate with third-party management systems. So you can, and in the old days, people would use SNMP to do this, but these days, we're moving towards, everyone is moving towards more API infrastructure. And so with our APIs, they're like, you can get almost 100% of what you could get from looking at the CLI or the GUI. I think it's a full, it's pretty a complete API set. All right, this is just a screenshot from looking at in the RF monitoring or in monitoring in the wireless management system, the Mojo wireless management system. And you can see that we're looking here, we're looking at radios. You can see we have AP, radios, clients, and wireless LANs. In the radios tab, though, it's pretty good. I mean, the kind of things that you like to look for when you're looking at an AP. And if we take a look at the C120 down here, the .73, I just put this one there because I know this is in our testing, in my performance testing lab, and I happen to have 52 clients connected to that one radio right now. And I was doing some performance testing, and basically I can look at the retry rate, which is a really important key performance indicator, as well as the utilization. And that's one of the things. Another one is the noise floor, which is very low, and then the worst client RSSI. And I'm not surprised to see that the worst client RSSI is -60 there, because it is a lab, and the clients are fairly close to the access point. But just wanted to put this up there as one place where you can go in the Mojo network management system to see some key performance indicators there. The next one is the client view. So here are some of those clients that are connected, and you can see they're all connected to perf test. That's my SSID where I'm doing the testing. I get the IP addresses of the devices, and I get the RSSI of the individual clients. It's all on the same channel, the same radio. And then I can look for the data usage over time in the upstream, downstream, and so on. This column here is the retry rate, and I can see if any clients are experiencing higher retry than others. So I'm looking at some of those key performance indicators there for our client health metrics. Another way you can monitor with the Mojo system the health of, well, in this case, a particular conversation with a radio. Here, what we're looking at is we have this client, that MAC address of that client. Say we were reported that they were having trouble, performance problems or connectivity problems or what have you. I could then use the AP to do a packet capture for that client, and then open it up in Mojo packets, and then look at, in this case, this is the time view. So along the x-axis here, we see the time in seconds. So it's a little over 12 seconds. Actually, this is from the 6-second mark to the 12 seconds. This is like 6 seconds of conversation. And we can see that we can look at what we have here is superimposed. We have in blue, the data rate and the frame size, the throughput RX and throughput TX. And that's pretty helpful. And if you look over here to the right, you can see in the blue column, or blue in the y-axis, is the data rate, and the green is the frame size, and throughput is in that orange color. So you can see basically the health of the conversation in a graphical way. Now, of course, you could use a packet capture, and you go through every packet. and then look at the data rates and the frame sizes. But this graphical representation makes it much easier for you to see right away the health of the conversation. Just to let you know, in the left side, we're not going to go into it now, but what you have here on the left side in the y-axis are all the frame types. And when you're looking at Mojo packets, you'll see that basically you'll start with the here down at the bottom where you get the association, and then finally you start transmitting data. And so in the future time, we'll probably do a full deep dive on Mojo packets because it's a lot to cover. But I just wanted to give you a glimpse of it here to give you an idea of how you can use Mojo packets to get just check the health of, in this case, a particular conversation from a client to an AP. Okay, so as far as third-party or applications, Skype for Business, or what was called Link before, you can look at the call metrics. And here we just want to take a look at like for instance, MOS, and that would be the average MOS, and then here we see min MOS. And so this is one way to just use a third-party application to keep track of some key performance indicators. And MOS definitely is probably the most important. MOS are our value for your voice calls. Also, as far as Spectrum Analyzer, I like to use MetaGeek on my laptop as a standalone Spectrum Analyzer, and so that way, if even just for a new installation, if you're going to an area and you've got a new building where you're going to be deploying Wi-Fi, and say you want to use a static channel plan, you can use MetaGeek to get a good indication of which channels. And in this particular view, you can see that channel utilization, or channel grade and channel utilization. So I can get an idea of which channels are clean in that particular area. Or for an existing installation where you want to just get an idea of which channels are being heavily utilized in a given area, you can use your MetaGeek Spectrum Analyzer on a laptop when you do a walkabout. All right, so planning. So I remember when I was working, I was a resident SE for a while for a previous company out at Xerox Palo Alto Research Center. And I worked with a network scientist there who was very methodical about his approach. And this is kind of where I get this from, this kind of take on how to do things. But he would basically do like a kind of a triage, for some problems that they would have, and he would then he would come up with a plan of action, and he would develop a hypothesis about what he's expected to see if we test one thing or another, or we change one thing or another. And that methodical approach has stuck with me because he was pretty successful. And so I just recommend that you do that. You take a very methodical approach to things, and you really just take one step at a time, and then you measure and so on and so forth. So that's why I kind of communicate that here. And now the troubleshooting optimization, there's so many different types of optimizations that you can make. I try to break them down into different categories. And so I got to step back a little bit because this is just a subset. There are even more optimizations that you can take. And really, I'm going to say that probably one of the best things you can do if you want to optimize your network or improve the performance of the network are, simple things. If you're 11N, you want to upgrade to 11AC, obviously. And if you're already 11AC and you're using 20 megahertz or 40 megahertz, you probably should think about using 80 megahertz, because there's nothing like, throwing more, it's not always a solution to throw bandwidth at the problem. But a lot of times with Wi-Fi, a lot of times problems can be solved by just adding more capacity. And so before diving into all these different optimizations, I just wanted to, mention that. Now, you can't always add more capacity. Sometimes you're using all the spectrum that you have available, and you just have to make the most of the spectrum you have here. And that's where these next 2 or 3 slides can help with trying to get the most out of what capacity you have. All right. And the first one is double or half the channel width. So that would be obviously adding more capacity. And the second one, adding more spectrum, enable DFS channels if possible. I know a lot of places haven't used DFS, again, because they've been warned by wireless LAN professionals saying, oh, no, don't use DFS, never use DFS. And, that's unfortunate because a lot of customers could be using DFS and they'd be really benefiting from having that extra spectrum available. Like we talked about in the previous webinars, I mean, with DFS in the US, you have 6 non-overlapping 80 megahertz channels. Now, when you wouldn't want to use DFS, if of course, if you're near sources of where you're going to be interfering with the primary uses of those channels, so like radar and so on. So weather radar, for instance, for channels 120, 124, and so on. You could remove those particular channels from your candidate list, so you'd still be able to use some of the DFS channels. So that's something to explore. And again, if you deploy 2.4 pervasively, even if you have some clients that you're not sure about, they may not be able to support DFS. If you have 2.4 and 5 gig pervasively deployed, the clients can only, they can get on 2.4. So you wouldn't, leave them high and dry. Another one tweak is adjusting carrier sense threshold, and that's where basically you're going to kind of try to ignore conversations that may be on the same channel, that would be on the same channel in the on an adjacent AP, so you can get channel reuse. You can get you'll be able to reuse those channels sooner. I won't go through all of these, but you can see there's a number of them, like increasing and decreasing AP transmit power. Again, the idea is to if you decrease the AP transmit power, you could potentially use that channel sooner, or to an AP that's nearer. You can reuse that without them interfering with one another. Of course, removing of non-Wi-Fi interference. Again, that's one of the other uses for the spectrum analyzer. Enable coverage hole prevention, for instance. Enable client load balancing, band steering, and optimize client to AP associations. That's one where we have a sticky client problem, and it still exists. Some clients, because Wi-Fi lets the client decide when to roam, right? And that's even with 11AC and even with 11AX, the client is still going to be making the decision. AX is the new 802.11 that we're expecting in to be available in products probably within 2 or 3 years. And even with that, those new standards, you're still letting the client is still making the decision. So what we have is a smart steering where we keep track of where the clients are located in terms of their ability to see other APs or other APs to see them. And so if a client's operating at a very low data rate or low signal strength, we can prompt it or encourage it to move to another AP that is better suited to service the client. And so that's one of the techniques for optimizing the client to AP associations. And if you can do that successfully, if you get all your clients operating at higher data rates, you're going to use the spectrum better, because that's what you want. You want all your clients and data APs to operate the higher data rates, and that gives more airtime for everyone and higher aggregate capacity for the network. Okay. Oh, another one, and we talked about this for the deployment best practices, where you're going to power off some of your or repurpose your 2.4 gigahertz radios, because most deployments are going to have way more 5 gigahertz spectrum than 2.4. And if you're designing your network for 5 gigahertz, you can be way over provisioned in 2.4, where you're having to reuse channel 1 and 6 and 11 in the US way too frequently, and you wouldn't be benefiting from that. You'd be better off just turning off some of those 2.4 gig radios. Okay, MAC layer optimizations, and some of these these optimizations, they may be RF / MAC, but I tried to break it down into distinct categories. And so for MAC layer optimizations, we enable QoS end-to-end. That's a deployment best practice, of course. So it's not just turning on ABC, application visibility and control, on your access points, but then also having your switches supported and honoring the QoS tags. And if you, even at the front end, having an ABC solution, or your switches tagging the traffic as it comes in from the internet to make sure that it's prioritized, and so on. And let's see, AP radio transmission scheduling adjustments. That's really to do with airtime fairness and that sort of thing. If you want to do some type of scheduling, most EPs these days have that built in. where you're going to do some kind of schedule tuning WM parameters. And some of these, by the way, some systems expose them, and usually you don't have to worry about doing these things, but these are some of the things that people have done in the past, I should say, to optimize the network. Most of the time these days, you don't want to mess with this, but people have done tuning of WM. I certainly have played with this in the past, and, can help, but it's a lot of trial and error. And it's really diminishing returns. But by modifying the WM parameters, you can sometimes get a little bit better performance for a specific type of scenario, use case scenario. And again, I won't go through all of these. There are too many to cover in this short webinar. But I'll talk about remove support for lower and higher data rates. Now, that's part of a deployment best practice that we already, certainly for high density, you want to remove your lower data rates so that you can, again, get the average data rates for a cell. You want to get those to be higher, and removing support for lower data rates can help with the sticky client problem somewhat, but it also can boost the overall throughput for capacity for a cell. But also you can sometimes remove higher data rates, because with 11AC, you have the ability to remove supports for MCS modulated coding scheme 8 and 9. And both 8 and 9 require 256 QAM, 256 quadrature amplitude modulation, which is that higher, denser modulation scheme. And to be able to support that higher modulation scheme, 256 QAM, you actually need to have a very high SNR. And so in some environments that are very noisy, you don't have that SNR. It's really not likely that you're going to get that high SNR. So you might want to remove those higher data rates, because what that does is it prevents clients and APs from trying to use those and wasting airtime, because they're not going to be successful. And then finally, with the packet loss, they would have a lot of retries. With the retries would lead to rate adaptation, lowering the rate that the client's using and the AP is using. And so you want to forego. You just want to not have to go through that process every time. So you can just remove those higher data rates, and that actually can improve performance. Let's see, broadcast multicast filtering, enabling broadcast multicast filtering or filtering and optimization. Yeah, you do that because especially with large flat networks, and there are some out there, especially some campuses, they do use like a /16 at the in network, and they'll have, it's so large and flat that you really want to broadcast. You want to filter the broadcast and multicast. You don't want them flooding your air and wasting airtime. So you want to enable some those features. Let's see, 11R, K, and V. Yeah, so talk about 11K and V. Yeah, those are not supported by all the clients. So you got to be careful. You can't just rely on K and V at this point to help with your client to AP optimization, because that's basically what those will do. They're looking at the available resources and then helping the client make a much more informed decision about which AP would be the best AP to go to get the most out of the resources in the air and so on. But not all clients support that. So even if you enable those, you got to keep in mind that you may still want to turn on smart steering so that for clients that don't support K and V, you can still encourage those clients to use the best AP. Multicast unicast conversion, yeah, that's another one you want, especially so if you have multicast, if you're using vBrick or Haivision or whatever system to put multicast traffic on the wire, you want to make sure that when it hits the AP, that multicast traffic gets converted to unicast, and it goes out at the nice high data rate that the client's connected at. You need IGMP snooping too at the AP so that traffic doesn't get flooded to all the clients on the AP or in the SSID, just the clients that have joined the multicast group. So yes, yeah, okay. Yeah, reduce management traffic by limiting the number of SSIDs and so on. Yeah. And let's see, but other optimizations, and probably one of the best things you can do is to get more 11AC wave 2 clients in on the network. If you take a look at what in the LTE world, that side of things, and the carriers, I mean, I'm talking on a phone that's got 4G, LTE, right? I'm sure most of you have phones that are capable of that as well. Because I mean, most of us get excited. Oh wow, 4G, LTE. I'm going to go out and get that. I need that. And I think on the carrier side, they've done a good job of encouraging and with trade-in programs and so on, upgrade programs to get their users to go with the new technology, right? On the Wi-Fi side, I don't think we do as good a job of that, and it's unfortunate because our networks, if we all went out and, if we made a better effort of encouraging folks to go get Wave 2 clients, that would make a big improvement in general to the performance of the network, and application performance and so on, the capacity of the network. And I think as a group, we need to just try to encourage, if at all possible, to upgrade to the newest technology, because it does make a difference, a huge difference. Just a little, editorial there aside. Okay, update client drivers is another type of enhancement that you can make or optimization you can make. However, I mean, we know, I'm sure from experience, I know I've had it where you've upgraded to the latest driver and it's actually worse. Of course, the vendors, they try to test when, they don't just release new drivers without doing some testing, but, they can't test every scenario, every access point and so on. So it's just something to keep in mind. I remember when I was doing some performance testing years ago, we actually had to use an old driver to get really good performance. It's just because when we upgraded the new driver, I won't mention the name of the company, the chipset vendor, but what they did, they made a conscious choice that in their future, on their updated drivers, the client would be more stable, but would have worse performance. I mean, it was significant. So, I mean, it was like almost, 100%, or better, when it was double the performance with the older driver than the newer driver. Yeah, the newer driver was more stable, but the performance was really, really bad. So that's something to keep in mind. And then other things you can do, like enable traffic shaping. You can rate limit clients. You can rate limit low priority traffic, block unwanted traffic, and so on. Infrastructure equipment upgrade, that would be, of course, your switches or your access points and so on. So, this is just a partial list. We can go on, but time is limited. And then troubleshooting optimization best practices. Again, it's about network management, but really, what is network management? But I mean, a lot of times network management comes down to, one troubleshoot or optimization effort after another. It's never ending. And so recommend that you refer to the vendor's AP vendor or whatever best practice or forums, etc., to get help. A lot of times they'll have guides for, for instance, a particular handset. Usually you can get a guide from the vendor or from the wireless LAN vendor or from the vendor themselves in terms of how to best, configure the system to make sure that the application or the handset works optimally and so on. And you want to follow change control best practices. This goes back to when I was, at the Xerox Palo Alto Research Center with the network science. They were very methodical, and they had a process, and not just there. A lot of huge companies, especially hospitals. I think that hospitals probably better than anyone else do a good job of having a methodical approach to making any changes on the network, especially for major upgrades or redesigns. They would always start with a POC. So you get whatever it is in the lab. You're gonna get new clients. Let's get them in the lab. New software for the AP. Let's put it in the lab, and let's test our applications, our use cases in the lab to make sure that basically we have some reassurance that we're going to get for at least in the lab they're going to work fine. Okay, you start there, and then you go to a limited pilot. So one section of the building, we're going to roll out those new devices or that new code on the APs or whatever it is, and we're going to make sure that now everything works in that limited rollout there before deploying pervasively. And of course, you want to measure and document everything before and after. Hopefully, you can do that in your some kind of system, so you can do some analysis on it for a later date. Reporting. Now we have some built-in reports, of course, and I just wanted to mention some of those here. So we have the bandwidth audit report, which can be helpful. You can look at low data rate that way, communication errors, AP utilization, and so on. Excessive associations, so clients, if they're ping-ponging around, that can definitely cause a lot of trouble. We have that one of those key performance indicators here. And then we have the RF audit report, which looks for coverage holes, noisy channels, channel crowding, etc. And then we also have a configuration audit report. So we want to look for configuration changes, RF configuration, and so on, bandwidth efficiency. And so these are just some of the built-in reports. You can customize your reports, and you can use third-party systems to run reports as well. For instance, with our API integrated into some third-party management system. All right. Lastly, I just want to before we get to Q&A, I just want to run through some issues and some remedies. And so we'll start with let's see. One area of the network is experiencing very poor performance for multiple applications and device types. So just one area of the network. Okay, these devices and applications are working fine elsewhere. Let's assume, and we noticed that we have a high retry rate and RF utilization rates for APs in that area, much higher than other areas of the network. Now, the possible cause here is that maybe we just need more spectrum in that area. Maybe it's just we are the channel utilization being high, which RF is equivalent to channel utilization, and retry rates are indicative that we're probably getting to the point where we could benefit from adding more capacity in that area. So one of the remedies may be to just double the channel width of the APs in that area, or maybe consider doubling the channel width pervasively. But if you say if you're running with 20 megahertz, you can go to 40 megahertz, and if you're 40, go to 80. Now that's if you have spectrum available. If you don't have spectrum available, then that goes back to all the other optimizations you might have to make in that particular area. But the easiest thing potentially would be to add more capacity, because let's face it, most of us we don't spend all day. We're not RF. We don't have PhDs in RF and all. So tweaking everything that you can tweak to get some more capacity out of that spectrum there, it can be very, very time consuming. So sometimes it's just easier to just add more capacity. All right, poor voice on the Cisco 7925 handset, which reported by a number of users. So in this case, it's not in one particular area of the network. It can happen anywhere, any user, anytime. And so the possible cause is that the voice traffic is using the video transmit queue. The reason why it would use the video transmit queue, for those of you that have used these phones, and not just these phones, a lot of other phones, they would tag the traffic as expedited forwarding at DIFSERD code point expedited forwarding, which would be decimal 46. In binary, if you look at it here, we see that we have a 101, 110. And with WMM, most of you would know this, but with WMM, it doesn't look at the whole 6 bits. It just looks at the first 3 bits. And that's how it would normally figure out which queue to use on the access point. And there are 4 queues on the access point, right? There's the voice queue, which is the high priority, the video queue, which follows, and then the best effort, and followed by the background. And you're going to have the different WMM parameters configured for each of those access categories. And so if the voice traffic from the Cisco phone is going into the video queue, that could be a problem, especially if there's video on the network, right? Because then it would be competing with the video traffic. The voice traffic would be competing with the video traffic, so to speak. It would be contending with, as far as like getting transmitted by the access point. So with our system, what we do is we would normally map the expedited forwarding. We would look and see, oh, okay, we see DSCP expedited forwarding, we know that that's how a lot of devices, handsets, and voice applications tag the voice traffic. So we're going to map that to the voice queue. But some systems don't do that. You have to manually do the mapping. There could be a problem with Cisco handsets. By the way, some of the features that I talk about and some of the problems that I talk about may not necessarily be a problem on our system, because in this case we have the feature that would automatically map it to the voice queue. But I try to make this presentation not just about Mojo networks and just in general knowledge. So, all right, issues Certain client types. Issue number 3, certain client types are experiencing poor performance. Loading web pages taking much longer than expected, for instance. And let's see, possible cause. You noticed, you did some troubleshooting and you looked at these clients and you noticed that these particular clients, when they're having problems, they tend to be connected to APs that are far away and they're using very, very low data rates. So that would be indicative of clients that are very sticky. They just try to hold on to APs, even though there are other APs in the area that are better suited for us, to service them. The client would operate at a higher data rate, and that would improve the client's performance. But also, when you get all the clients operating at high data rates, that improves the aggregate capacity of the cell, or that AP, that radio in general, right? So one of the things you could do is that you could enable smart steering or 11K and V if the clients support it. But smart steering is something that you can do even if the clients don't have support for K and V. And you can do, again, that'll keep track of the clients and the APs that the clients can see, the APs if they can see the clients and vice versa. And then you can know that below a certain signal strength, this client is a candidate to get moved to another AP or get encouraged to move to another AP. The client has to make the decision. The only thing that the infrastructure can do, the APs can do, is to encourage the client to move to another AP. So you may want to enable smart steering. I say results because you're just getting back to that methodology where you're keeping, good notes on the what happened and so on. Because if you're going to try one thing at a time, it's always good to see, because we can all get so busy. Sometimes, one problem can, get confused with another. I know it's happened to me. So anyways, issue number 4, in certain areas of the building, the network seems to be performing much worse over the past week. And possible cause is that APs that are adjacent to one another are operating on the same channel. You wouldn't think that this happens, but it does. It happens when we use static channel plans, but it also happens when we use auto channel. I'm not speaking specifically about our auto channel or anyone's auto channel capabilities, but sometimes it does happen. And when APs are operating on the same channel and they're next to each other, you're going to get Cochannel interference. And in some cases, you can have APs that are operating on adjacent channels to one another. But if they're close enough, let's say you have a pretty high density deployment and you have APs like 20 feet apart from each other or 30 feet apart from each other, and they're operating on adjacent channels, you can have adjacent channel interference where the sidebands are, interfering with the AP next to it. And so you want to either enable auto channel, and hopefully your auto channel is behaving properly, and it would avoid that type of deployment or configuration, or modify your static channel plan to avoid co-channel interference as well as adjacent channel interference. It's worth pointing this out because really we do see, and over the years there've been lots of situations and site surveys done, and see that APs are all operating on the same channel in the same area. All right, issue number 5. The network is currently unable to deliver high-definition instructional video to 30 students using 11AC Wave 1 Chromebooks simultaneously, and these are 1x1 Chromebooks. So they're going to connect at PHY rate or max data rate of 433 megabits per second. Let's see, it's a 1x1. Yeah, 1x1. Oh, I'm sorry, I stand corrected. It's a 40 megahertz channel. So they're going to connect it at 200 megabits per second. So that's the data rate that this group of clients are going to connect at. That's a max data rate, assuming they're all in the same, it's in a classroom. So they're going to be relatively close to the AP. So they're all probably connecting between 150 and 200 megabits per second, let's say, at least initially, before they start trying to all trying to get that 3 meg SLA. I got a typo because in the second line, it says that struggle to support 5 meg. It's 3 meg. 3 meg SLA. 5 would be really, really hard. So if you look at this, you might think, well, geez, it's only a 3 meg video. And we got 30 students. What's that? That's an aggregate throughput of 90 megabits per second. Surely I can support 90 megabits per second on a 40 megahertz channel, with 11AC. Yeah, aggregate throughput you could, right? But one thing you have to keep in mind is that Wi-Fi is not going to do perfect throughput fairness. You have things like airtime fairness, but that's not throughput fairness per se, right? It depends if all the clients are operating at the same data rates, then airtime fairness would equal throughput fairness. But the way Wi-Fi works is, we're going to see that some clients are going to do better than others, even when you have good, scheduling and so on at the radio. So supporting 30 students in a 3 meg SLA and 40 megahertz actually is very, very challenging. And I haven't seen, and I do a lot of competitive performance testing, of course, and I have for many years, and I haven't seen APs do a good job of that, right? So what you usually have to do is you usually have to have more capacity because you're not going to get perfect throughput fairness to support this 3 megabits per second SLA per laptop. So the remedy would be maybe to switch to an 80 megahertz channel plan if the spectrum's available. If not, if the spectrum's not available, you have basically two other choices, more or less. One would be to lower the bit rate. So just send a bit rate instead of a 3 meg video, maybe send a 1.5 meg video or 2 meg video, something like that. The other thing you could do is, again, purchase 11AC Wave 2 Chromebooks. Obviously, that's not easy to do. You can't just go out and equip all of the students with Wave 2 Chromebooks. But I just want to make the point that would probably be the one of the best ways ultimately, especially if you don't have the spectrum available, it would be to upgrade the client types, because client types really, really, really matter in terms of getting the most out of the available spectrum. They matter as much as the type of APs that you're using. So that was issue number 5, and so that's it for the issues. So just wanted to, and before going to the QA, just summarize that, the approach that we use was very much looking at key performance indicators and then coming up with a plan to how to optimize things, even before you get calls to the help desk, to just constantly stay on top of things and proactively trying to constantly improve the network so that you stave off, you don't get those calls to the help desk. And because if you look at survey after survey after survey, I saw one this morning actually before I started this call, and it said that 85% of the people surveyed they can't do their job because of poor Wi-Fi problems. Now, probably some of those aren't really poor Wi-Fi problems, but that's perception. Maybe, who knows, maybe 30, 40% are actually due to poor Wi-Fi problems. Maybe 20% due to internet uplink problems or some other types of problems, infrastructure problems. But nevertheless, a lot of people do lose work or the ability to get their work done because of Wi-Fi problems. So if we can take this really proactive approach to network monitoring and just constantly trying to tune and optimize the network for performance for all applications and all devices everywhere all the time, I think that'll go a long way for customer satisfaction and help people business run smoothly. All right, with that, I'm going to take a look and see which questions we have here. All right, so first question is, can you list the top key KPIs wireless LAN managers should track? Yeah, so I listed some of them earlier on, but would be, say, like channel utilization and retry rates. Those are really key, because you're not going to have a good performing network once your retry rates get above 20, 25, 30%. Wow, things go south quickly. And high utilization rates above 50, 60%. That's when your retry rates go up and performance starts suffering, and it can really snowball and get much worse quickly. MOS is one that I would also look at, and that for mean opinion score for voice, or media delivery index for video, if you have a system that tracks that. Average TX and RX data rates, AP uptime, internet uplink utilization. Again, a lot of times people are probably reporting problems with Wi-Fi, and it really is the internet uplink utilization. In the old days, most of the services for a network were local, right? They were in a data center. But as we go to software as a service, and we have a lot of services and applications running on in the cloud, that becomes more important that you have the network uplink capacity to the internet to be able to support that type of model. Let's see. Question 2: which third-party wireless LAN tools do you recommend? Well, iPerf is a good one. That is built into it's open source, of course, for simple performance testing, right? You can do simple single client throughput tests, easy TCP, UDP, upstream, downstream, and so on. But another one I like to use is the IX Chariot. Now, IX Chariot, most of you probably don't have it, but we do see IX Chariot being used when there are like POCs. Sometimes the customer will get IX Chariot or something similar to IX Chariot, where they can simulate traffic and send traffic to a large number of clients, because they're trying to see if the network is capable of supporting their actual users. So they can use IX Chariot, where you can simulate voice, video, and data traffic to a number of clients. You can 50 clients, 100 clients, and these are real clients, right? Because the way IX Chariot works is you have the endpoint, the IX Chariot endpoint installed on the individual client, whether they're iOS clients, Mac OS, Windows, Android, etc., Chromebook, and that way you can send traffic and simulate your use case to make sure that your network's going to be able to handle the actual use case. So that's one that we see, but that's more for in the POC stage of things. VLC also, if you don't have, if you can't get IX Chariot, but you want to do some POC testing, getting ready for deployment, you can use VLC, which is open source video streaming, and you can just try to stream like an HD video to a number of clients, 10 clients, 20, 30, 40, to make sure you're able to support that use case. So those are more for the POC side of things before you do your deployment. So it's not so much for network management, but more for the earlier step number 2 or session number 2 when pre-deployment. Channelizer, spectrum analyzer. I like that one because you have a little dongle and you put on your laptop, and you can go around and do some spectrum analysis real time anywhere. Speed test, that's just the application on your phone or your tablet, or you can run it from the web, your laptop, to just check. It's not a great way to do performance testing per se, but if you just want to see if what the health of the connection speed is, you're testing two things, right? You're testing your internet uplink, and you're testing your over-the-air RF, and also your switching infrastructure. But usually, when you do speed tests, you run that app on your phone or your tablet or something like that. Most of the time, the internet is going to be, unless you're very lucky to have a great, pipe to the internet. Most of the time, your internet is going to be the limiting factor there. But if you have a really, really big pipe to the internet, then you can get an idea of maybe the capacity for the access point that you're connected to. Let's see. Wi-Fi analyzer. That's another tool application that I run, and it just shows me the SSIDs in the air and the channels that they're using and so on. NetSpot's another version of that. NetSpot does a couple of things. We have it on our Macs, and it shows you the SSIDs in the air, which channels they're on, and so on, the signal strength and all that. But NetSpot also has a built-in, you can use it for simple site surveys, post-deployment site surveys, which is pretty cool. It's a poor man's version of like an Ekahau or something like that, because it's way, way less. It doesn't do everything Ekahau does, but it's like I said, it's very relatively inexpensive. Let's see. Question number 3. Will you be doing a wireless LAN security management focused webinar anytime soon? I don't know if we have one scheduled where we're going to be specifically talking about security management, but we've done a number of them in the past, and so I'm sure some of them are available for download on demand. And so you'll be able to find those in the on-demand section of our website. All right. Let's see. I think that is about it. So Erica, back over to you.
Great. Thank you, Robert. Thank you again, everyone, for taking the time out of your day to join us. It looks like that's all the questions we have for now. But again, if you do have any more questions, you can feel free to contact us at myrep@mojonetworks.com. So I just wanted to quickly review a free access point for anyone who does qualify. Unfortunately, our valued partners and resellers are ineligible to receive free access points. But of course, if you have questions, you can contact us. Anyone who has received one previously or already has an organization with a free Mojo access point, you are ineligible. You can always check those qualification requirements, but we will also be reaching out to you to confirm your qualification and also confirm your shipping address, because we also need to make sure we're going to ship you this access point to the correct location. If you have any questions, you can feel free to call us at the phone number listed, 877-930-6394. And if you've already qualified for a free access point, we can also talk to you about a free 14-day trial. So we'd love to get our products in your hands. If you have any more interest in testing us out, just let us know and we'll work with you. That wraps our webinar for today. This will be available on demand. As I also put in the chat window, if you missed parts 1 and 2, you can also watch those on demand if you just go ahead and click the link. And don't miss our webinar coming up next week with CEO Rick Wilmer and Senior Analyst for More Insights, John Crew. They're going to be talking about our new business model that we launched just about 2 weeks ago, and really how we're revolutionizing the Wi-Fi space. It's really exciting. I think there's a lot of very interesting information, including how our customers are going to be able to save up to 50%. So I highly suggest you join, and the link is right there in the chat window. Thank you, everyone, and we look forward to seeing you on our next webinar.